All right, so we are going to look at what is the triangle inequality theorem. So before I do this, I want to go over certain facts. All right, so let's see. There are different ways of proving triangles congruent, and I am going to tell you this right now, so in the future when I go over this lesson you already have an insight or an understanding of what's going on. I can prove triangles congruent by side, side, side. What is that? Well, means the following. If you have three sides of a triangle, okay, congruent to three sides of another triangle, like this, then the triangles are congruent. As simple as that. If all three lengths are congruent, like this side is congruent to this one to this one, this one to this one, then guess what? The triangles are congruent by the side, side, side theorem. All right, now another one. If you have two sides of a triangle, okay, congruent to the other triangle, and you also have an included angle right here, congruent, then the triangles are congruent by side, angle, side. See that? Side, angle, side. Two sides and the included angle. Also, if you have okay, if you have two angles of a triangle congruent to two angles of the other triangle and the included side, then the triangles are congruent by angle, side, angle. Angle, side, angle. So far, what do we have? We have side, 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 angle, side, angle, side, angle. All right, so how about angle, angle, angle? How about if all three angles of one triangle are congruent to all three angles of the other triangle? Guess what? You cannot prove that these two triangles are congruent. Okay? You cannot. What you can prove is that they are similar. Okay? Or instead of angle, 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 you could say angle, angle. Duh. If you have two angles of one triangle congruent to two angles of the other triangle, the third angle will have to be the same because the sum of the angles in a triangle is 180. Unfortunately, we can give a counterexample by drawing a right triangle right here. Okay, 90. All right. So we could say that these two sides are congruent. These two sides are congruent. Okay. Not really. They're not congruent. What was I gonna say? Oh, I'm sorry. Not the sides. That these two angles are congruent to these two angles right here. This could be 45 and this could be 45 degrees. This is 90. So 45, 45, 45, 45. Okay. Now, just because all the angles are congruent doesn't mean that they have to have the same everything. This triangle, this is a right triangle, right isosceles triangle. This side is congruent to this side, and this side is congruent to this side, but they're not the same length. Okay? So angle, angle, angle does not prove triangles congruent. It only proves that they are similar, meaning that they have the same shape and the same size. Okay. What else do you need to know? Easy. Let's have one of the triangles. Now let's just create our own triangle. Okay, my triangle. Let's say this is 8, this is 12. Well, I'm gonna tell you right now, the measure of this cannot be 20. Okay? It could be 21, it could be 22, it could be more than that. Why is it that it cannot be 20? Well, there is a theorem, okay, that says that the sum of any two sides of a triangle has to be greater than the third side. For example, oh gosh, oh my god, I made a mistake. This cannot be 21. This gotta be 19. It could be 18. It could be 17. I'm gonna prove it to you right now. Okay, 12 plus 8 is 20. 20 is greater than 19? Yes. Okay, so it checks. 8 plus 19 is 27. Is 27 greater than 12? Yes. 19 plus 12 is some number, 29. No, 31, sorry. Is 31. Is 31 greater than 8? Yes. So then, this can be a triangle. So that's what it says. The sum of any two sides, the combination, okay, you gotta try all combinations. The sum of any two sides of a triangle has to be greater than the third side. And now let's start our lesson. Wow, I just spent 8 minutes on this. No, 6 minutes. All right, cool. So that's what it says. The triangle inequality theorem. All right. The sum, look, if you take the length of B and the length of C, it will be greater than the length of A. If you take the length of B plus the length of A, has to be greater than the length of C, and so on and so forth. Wow, somebody's cooking. All right, and then we have our three choices. Not choices, but we have our three, what do you call that? Three situations. So A plus B has to be greater than C. A plus C has to be greater than B. And B plus C has to be greater than A, the sides, right? And that's how it goes. All right. What else did I, oh gosh, I forgot. I gotta teach you something else. Look, if you have a triangle, right? Let's say something like this. Oh, okay. So if you have a triangle, okay, let's say this side measures 15, this side measures 11, and this side measures 8. Okay, and I want to know the order of the angles from smallest to largest. So there is one way of knowing this. Opposite to the shortest side is the smallest angle. Let's give this a name, A, B, and C. Okay, so right now, since this is the shortest side, then opposite to that is the smallest angle. So the smallest angle is C. Now, guess what? C is less than, and now let's find out which one is the next smallest angle. Well, opposite to the shortest side is the smallest angle. And guess what? Opposite to the longest side is the largest angle. So this right here, angle A is the largest. That means that measure of angle B is between the smallest and the largest. So angle B, and angle B is less than angle A. Got it? So once again, opposite to the shortest side is the smallest angle. Opposite to the longest side is the largest angle. And vice versa. The converse is also true. Opposite to the largest angle is the longest side. Opposite to the smallest angle is the shortest side. Okay, so with that in mind, we could go ahead and start working on our problems. Okay, I have not done these problems, but anyways. So example number 1. 3 segments have length A3, B6, and C4. So I want to create my triangle, okay? So let's see, 3 centimeters. A is going to be 3 centimeters. 1, 2, 3. B is going to be 6. Okay, so let's see now. 1, 2, 3, 4, 5, 6. And the other one's going to have 4. So anyways, that's not how you do it, but regardless. So we say that this is 3, right? This is 6, and this is 4 centimeters. So we have, and we're talking about segments, right? So 3 segments have lengths of A, 3, B, okay. So this is segment A, this is segment B, and this is segment C. What can a triangle be formed with these segments? I don't know. Let's see. 6 plus 3 greater than 4? Yes. 3 plus 4 greater than 6? Yes. 6 plus 4 greater than 3? Yes. So yes, a triangle can be formed using these measures. So you're right. Yes, a triangle can be formed using these measures. Let's go to example number 2. So a triangle, I'm just going to draw any triangle. It's not drawn to scale, so don't even think about saying, oh yeah, he didn't do it right. So I'm going to say that A, let's see, A is 7. So I'm going to call this A, 7. B is going to be 16. And C is going to be 8. Okay, we're talking about the length. Notice that I didn't put the letters in capital letters right here because that would denote the measure of an angle. No, I put it between. Okay, so let's see if this is a triangle. Okay, 7 plus 16 greater than 8? Yes. 16 plus 8 greater than 7? Yes. 8 plus 7 is 15. 15 is not greater than 16, so no, a triangle cannot be formed. Okay, so let's see what it says here. Alright, so we have this length right here. The length of DB could be. So I want to know what this length can be if this is supposed to be a triangle. Well, let's see. Can X be 5? If this is 5, okay, if this is 5, let me just go ahead and zoom in. If this is 5, then that will make AB 11, because 6 plus 5 is 11. So let's see. 11 plus 17 is 18. Is 18 greater than 18? No. So X cannot be 5. Let's try 12. So if X is 12, this becomes 18, correct? 18 plus 7 greater than 18? Yes. 7 plus 18 greater than 18? Yes. 18 plus 18 greater than 7? Yes. So this could be the measure of dB. Alright. Now, why not 19 or 25? Well, I could put 19 in here. 19 plus 6 is 25. So this length will be 25. So let's see. 18 plus 7 is 25. 25 is not greater than 25, so this cannot be. And the same goes for this one. Okay. Which set of numbers represents the length of the sides of a triangle? Remember, I'm not talking about a right triangle, so let's not assume that we have to use Pythagoras theorem. We're dealing with the size, with the what? Triangle inequality theorem. So let's see. 5 plus 18 greater than 13? Yes. 13 plus 5, 18. Greater than 18? No. Okay. 6 plus 7 is 23. Greater than 22? Yes. 22 plus 6 greater than 17? Yes. 17 plus 22 greater than 6? Yes. So this could be the length of the size of a triangle. Okay, in triangle ABC, AB is 5 feet, BC is 3. Which inequality represents all possible values for the length of AC? I don't know. Let's see. I have a triangle, right? A, B, and C. AB is 5. BC is 3. So now which could be the length of AC? Well, let's see. Can AC be 2? 2 plus 3 is 5. Not greater than 5. So here AC cannot be AC cannot not start at 2. So no, this one doesn't work. Because remember, it says less than or equal. That means that it could be equal to 2. So, but we cannot use the 2 over here. Okay? So how about this one? 3. Let's see. If this was 3, 3 plus 3 is 6. Greater than 5? Yes. 5 plus 3, 8. Greater than 3? Yes. 5 plus 3, 8. Greater than 3? Yes. All right then. And now stops at 7. Let's see. If this is 7, 7 plus 3, 10. Greater than that? Yes. 5 plus 3, 8. Greater than 7? Yes. 7 plus 5, 12. Greater than 3? Yes. So this could be the length of a triangle. And that's it. Okay. Let's move on to the next one. In PQR, okay, let's do a triangle. Let's see what's up. Alright, so that's your triangle right here. And now it says PQ is 8. Okay, PQR. PQ is 8. QR is 12. RP is 13. What statement about the angles of this triangle is true? And look at this. It's saying that the measure of angle Q is greater than the measure of angle P, and the measure of angle P is also greater than the measure of angle R. How am I going to know the hierarchy of these angles? How, in which order? Well, look at this. It says that this is greater than this one, and this one is greater than this one. So therefore, this one is greater than all of them. Same thing here, same thing here, same thing here. So they want us to arrange the angles from greatest to smallest. That's not a problem. Which one is the largest angle right here? Exactly, angle Q. Why? Because it's opposite to the longest side. So we got angle Q greater than the next largest angle would be, well, the next largest side is 12. So opposite to that is angle P. So we'll talk about P, and of course the last one will be R. So we got QPR. QPR, and our answer is choice number 1. Okay. In triangle ABC, AB is 7. Okay, so we got a little triangle right here. Boom, boom, boom. A, B, and C. We got AB being 7. BC is 8. And AC is 9. Okay. Which list has the angles of triangle ABC in order from smallest to largest? Okay, smallest to largest. So first of all, let's identify the smallest angle. Well, remember, opposite to the shortest side is the smallest angle. So angle C is the smallest. The next smallest, well, is 8 is the next smallest side. So opposite to 8 is angle A. So it'll be CA. And of course, I just look for the other letter, CAB. So correct choice is choice number 4. Wow. How much more do I have to do? I don't know. All right. I'm not going to be solving all the problems because I just gave you the concept. So you need to use your little noodle, okay, in order to answer them. All right. In triangle ABC, so I have triangle ABC. Boom, boom, boom. Okay. A, B, C. Measure of angle A is 95. 95. Measure of angle B is 50. Measure of angle C is 35. Okay, degrees, of course. Which expression correctly relates the length of these sides of this triangle? Justify your response. Okay, so which of these expression relates to the sides of this triangle? All right, so first you gotta look at this symbol right here. It's a less than. Since it's a less than, that means that they want us to order the sides from smallest to largest. Okay, so the smallest side, well, this is the smallest angle. So AB should be the shortest side. The next smallest one is 50. Opposite to 50, we have AC. And of course, the largest is A. So opposite to angle A, we have BC. So AB, AC, BC. Boom. Choice number 2. Got that? Okay then. Let's see now. Scalene triangle ABC. Measure of B is 45, measure of C is 55. What is the order of the sides from longest to shortest? So just, create your visual, okay? We're talking about triangle ABC, so ABC. Angle B is 45. Angle C is 55, okay? I don't know what angle A is, but you know what? It doesn't matter. I know that the sum of the angles in a triangle is 180. So 45 plus 55 is 100. So angle A is 80. And now I just have to arrange them from longest to shortest. Remember, opposite to the largest angle is the longest side. Opposite to the shortest angle is to the smallest angle is the shortest side. And this one goes in the middle, right? Okay, good. And then you answer it, of course. Once again, this one, just draw a visual, okay? Label. If they only give you 2 angles, you could figure out the third angle because the angles in a triangle add up to 180. And then this one says that you are ordering the size from smallest to largest. Look, this one is smaller than this one, and this one is smaller than that one. And you figure it out. Draw a visual. Right here. It says, which side of A is the okay, I need to know which side of triangle ABC is the longest. Well, what do I know about this angle? This is an exterior angle of a triangle. Therefore, the exterior angle of a triangle is equal to the sum of the two non-adjacent angles. So, how am I going to figure that out? Well, think of it. 37 plus what is 117? That's 80, right there. Okay. And now remember, this is a linear pair. So, I need to know what is this angle right here. So this angle is 63. Now I got all the angles. And now, which side of triangle ABC is the longest, and tell me why. I already repeated it a couple of times. Opposite to the longest angle, sorry, to the largest angle is the longest side. Opposite to the smallest angle is the shortest side, and vice versa. All right, so I'll see you on the next lesson, okay? Bye-bye.